Okay, this is the second video where we're covering the section number 3 in your Unit 4, Unit 5 flipbook. Section number 3 is standard form quadratic. And in the last video class, we went ahead and did the top flap, which talks about how to find the vertex of a standard form quadratic. And then we also talked about, actually did some review, how to find the y-intercept, which is just the value of c. And what does the a value do to the graph? It changes the direction and the shape. And then how does c affect the graph? As c gets bigger, the graph shifts up. And as c gets smaller and goes negative, the graph shifts down. So the c affects the graph by causing a vertical shift. And I can actually add right here a vertical shift. Let's do that. It's going to be arrow facing up and down, letting you know that the graph moves up and down as c changes. Alright, so now we get to the difficult part, or the new part, and that is how to find the x-intercepts of a standard form quadratic directly. We have figured out how to find them indirectly. We can take the standard form quadratic and change it to intercept form by factoring and then find the x-intercepts that way. But today we're going to learn how to actually directly find the x-intercepts of a standard form quadratic. And we do that using the quadratic formula. The quadratic, I'm going to try to write that neatly if I can. It's already pretty messy, so I apologize. In fact, just get rid of that and start over again. Quadratic formula. And this is a formula that can be memorized. I will tell you, I'm not going to require you to memorize it, but you certainly should know how to use it. And here is the quadratic formula. The x-intercepts of a standard form quadratic can be found with the formula negative b plus or minus, meaning there could be two x-intercepts, plus or minus the square root of b squared minus 4 times the value of a times the value of c. And this whole thing, that's our numerator, and our denominator is 2a. So if you plug in the values of a, b, and c into this equation, you're going to find the x-intercepts. And let me see, the thing you want to know about this also is if you're going to find the x-intercepts, the value of a, b, c has to be found after you set the equation equal to 0. So I'm going to put a little note here. You must set the equation equal to 0 before, I'll put the word before, let's underline it, before identifying a, b, and c. The reason this is because we know the x-intercepts are found when y equals 0. So if one side of the equation is equal to 0, we're finding the x values that cause the equation to be equal to 0. When you get equations, standard form equations, you can remember here, a quick example of that is, what if the equation was 2x squared plus 3 is equal to negative 4x? You can't find a, b, and c until you get everything over to one side of the equation. The other side is 0, and now you can identify a, b, and c. And you've already done that in a number of different places. Alright, so let's go ahead and use the quadratic formula. If you remember on the top flap, we have this practice equation that we're using, and that was y equals negative 4x squared plus 4x plus 8. So in our first step, we're going to make sure this whole thing is equal to 0. Everything is already on one side. All we got to do is set y equal to 0. So we're going to write the equation this way. Negative 4x squared plus 4x plus 8 is equal to 0. And now we're going to find the x values that make this equation true, and those will be our x-intercepts. All right. Let's go ahead and find the value of a. A is negative 1. b is 4, and c equals 4. Actually, c does not equal 4. Let's fix that. C equals 8. Okay, now I'll tell you, class, if you try to plug this whole equation into your calculator at one time, it is very messy. It can be done, but it is difficult to do. I recommend that you break this equation up into 2 steps. The first step is you find what's called, I'm going to put find the discriminant. Find the discriminant. The discriminant is this part right here inside the square root, b squared minus 4ac. If we find that first, it makes it a lot easier to work with the rest of the equation. So let's find out what b squared minus 4ac equals. Well, our b value is 4, so we're going to go ahead and write this. Remember, whenever you plug something into an equation, replace a variable with a number, you always use parentheses. So we're going to write 4 squared minus 4. Our a value is negative 1, and our c value is 8. So you can see I just plugged in b squared minus 4a, there's a, and there's c. Now when you put that in your calculator, you're going to get, you know what, I don't know why I did this, 4ac. Hang on one second here. Oh, I see, class, I made a mistake over here. Wow, I'm off my game right now. The a value here is not negative 1. The a value is negative 4. Let's correct that. So that means it's 4 squared minus 4 times a, which is negative 4, times negative 4 times 8. If you put this in your calculator exactly the way you see it, you're going to end up with the number 144. So that is our discriminant, 144. This makes the next step a whole lot easier. Step number 2 is now we can actually find the x-intercepts. Well, now we know the x-intercepts are going to be x is equal to negative b, let's just go ahead and write this out, negative b plus or minus the square root of, we already found this, class, the discriminant is 144, so we're going to write 144 divided by 2a. So all we have to do now is, let's finish plugging in our b and our a value. So I'm going to write down here, therefore x is equal to negative b. Now b is 4, so in the equation it flips the sign, so now it is negative 4. Remember, that negative here in the equation means flip the sign. It doesn't mean b will always be negative here. It means change the sign of b when you put it in the equation. So you got negative 4 plus or minus the square root of 144 over 2 times a, which is negative 4. Let's go ahead and finish that up. So I'll write that one more time. Now we'll go ahead and resolve the denominator. So we've got again negative 4 plus or minus the square root of 144 over 2 times negative 4, which is negative 8. So that expression represents our x-intercepts. Now we're going to go up to step number 3. We're almost done already. Step number 3, let's change colors here. So step number 3. Now this is a step that sometimes you have to do and sometimes you don't. This step says simplify the square root if it is a perfect square. So that means if the discriminant has a perfect square to it, if you square root 144 and you get a whole number, it's a perfect square, and we're going to go ahead and resolve that square root. That means we're going to convert it to a whole number. If you put in your calculator the square root of 144 and it gives you a bunch of decimals, just leave it as the square root of 144. We'll resolve it in the last step. But let's check this. We'll pull up our calculator here, and let's take a look and see. So I'm going to clear this, and let's do the square root of 144. And we press equals, it's exactly 12. That means this is a perfect square, and therefore we can convert it to 12. So let's do that. So in this case, I'm going to write, in this step, the square root of 144 happens to be exactly 12. So we're going to simplify it in our final answer. So step number 4 is write final answer. So now we can go back and take a look at our number from, or our answer from number 2. We're going to replace the square root of 144 with 12 because that was a perfect square. So in this case, we can write our final answer. X is going to be equal to, it can be equal to two different numbers. So let's put that in pointy brackets because that means a set of numbers. It can either be, take a look at our step 2, it can either be -4 minus square root of 144, which is 12, all over -8. This is all coming pretty much from step 2. Or our x value can be -4 plus 12 over -8, and close that with a pointy bracket. So this plus or minus our discriminant means you've got two answers. We can either subtract the discriminant from the final answer or add it to the final answer. And let's put this in our calculator to get our answers. So x can be equal to, let's try the first one. I'll clear this. We've got parenthesis -4 minus 12, close parentheses, divided by -8. Our first solution is 2. So in on our flip book, we'll say that our x-intercept can be 2. Our other one, let's do the other one. So parentheses -4 plus 12, close parentheses, divided by -8. When we add 12, we get -1. So our x-intercepts for this particular equation can be at 2 or at -1. Let's finish this up with some information real quick on the discriminant. This discriminant class, this b squared minus 4ac, this provides you with some pretty interesting information about your x-intercepts. So down here in this box, write the word discriminant. And here's what you can learn from the discriminant. In this case, you saw that we end up with 144. Here's the discriminant will tell you. If the discriminant is 0, if it's 0, that means we have one x-intercept, or one real, we'll call it a 0 instead of an x-intercept. We know that x-intercepts can also be called zeros. If the discriminant is 0, that means we have one x-intercept. If the discriminant is 1, sorry, if the discriminant is positive, if positive, then we have two real zeros, or two x-intercepts. And if the discriminant is negative, if it's negative, we have no real zeros. By real, we mean real numbers. I'm going to write out of the box here. So what we're learning is, when you find the discriminant, if it's positive, that means you're going to find two x-intercepts. If it's 0, if it comes up to 0, you're going to end up with one x-intercept. If it's negative, then your parabola never crosses the x-axis. That means there are no real zeros. You can't find the value of a negative number. If you square root it, you cannot get a square root of a negative number that's a real number.